November 16th, 2013. We're looking at the sunspots, guys, and this is Earth-facing images. Now, what's happened is 1897 has went beta gamma delta, which makes it capable of X-flares, and it's a smaller system, but the area is large. It's not a large sunspot in it. It's just a group of very small ones. Check that out. Now, 1899 is the big one we've been watching in the top left there. In the white circle, they're watching a sunspot develop. Now, that's the Earth-facing line. These are also Earth-facing SOHO LASCO C2 images. When you're Earth-facing, ISON is approaching from the right. What we're looking at is we have two stationary objects that have been parked here for about 3 days. Now, you notice you've seen planets come across here, and you see the stars move. Actually, the stars aren't moving. The satellite's LASCO is moving, and we see it orbit, and that's why you see that star field change. But there's two objects that have been parked here. They're not lens flares. You can see if you've ever seen a lens flare. And something interesting about the one on the bottom, just above the timestamp here. If I go, and I noticed it, and so I kind of put it into frame by frame as we watch it. Again, this one, the one above it, are both stationary. I want to show you something. There's the bottom one. Next frame, this object seems to project from it. There. You see it there. Now, guys, we've all read Ezekiel about the chariots there. The chariots of fire, actually, if you read them, they're spacecraft. If the angels used them then, would they use them now? And have you thought about how the angel's going to pour out a vial upon the sun? Very unique images on LASCO. I've never seen it before. These are the combined shots. Gives you the energy for the last 4 days. Excuse me, 3 days, 14th, 15th, and 16th, guys. To the right again is the comet side of Inky, Lovejoy, and ISON. Look at this crater this sunspot has created in the surface. That's what it looks like. And notice the vibration, just like in the video with the sound of the sun, guys, across this. But this is a huge crater. It's amazing the size of it. It's turning Earth facing when it's in the exact center of this picture you're looking at. It will be. Now, looking back at SDO, which is also Earth-facing images, there's the sunspot in the bottom that's become capable of X-flares. Look on the left side at the filaments rising there as it comes around. You notice that M flare that came off right there. Not an X flare. The energy seems to be building. There's activity all around the sun. Again, the comet side is the opposite side to the right of these again. And what we're watching is right there in the middle, in the bottom, coming towards Earth. As ISON comes in to the right, energizing the Earth, that sunspot's becoming X capable. So we got to watch for the perfect storm on this situation, guys. If it starts to grow, we'll know. Now you see Venus come in. This is stereo ahead, a different satellite altogether. Opposite side of the sun is the Earth, in orbit in front of the Earth, looking back at it. Now switching back to the 1A camera on HI, and this is stereo A. This is the one we watched Comet Inky in the left come in. And guys, if you don't know about Inky, it's been around a while, and it has had impacts on the Earth before. There it is as we go through the frame. It's flaring out both sides in these images as those solar flares affect it. And as it crosses the stars, it will appear to widen out. This is a close-up, but look, guys, Inky is where we get the Taurid meteor showers we encountered in the northern and the southern Taurids across November and the beta Taurids in late June and early July. Also, the Tunguska event, 1908, you know, where you've seen those pictures with all the trees blown down. They think that was a piece of Inky, guys. So we watch them all. Again, this is not a sun grazer or sun diver. This is an outer orbit, but because a piece broke up, and when would it do it? It would do it during a solar flare where the comet heated, expanded, and broke apart. stars, the one on the left will dim out. And I'm going to point it out, but as it dims out, that's the passing of ISON over it. It will become a blur. See here? Just watch the two stars that are coming to the center now. ISON just went across them. Now it got brighter there as it has been in the last few days in these last few frames. Again, if you're looking at it come off that wingtip of the satellite, move out towards the sun, just in the path that it's showing, and you will see it. And this is the reason why. It's getting so fast and close to the sun that the temperature and the density is increasing, guys, and we're getting a bow shock now on ISON. So bright we can't see the inner workings, but you can see that bow shock. Now, how long this is going to survive, I don't know. I went through a couple different temperature gradients here. You see the outer comma has expanded, but the bow shock is in the purple, and it's having the tremendous brightening effect on the inner nucleus group. And guys, this is what we're going to be dealing with. That tail that's coming behind ISON is what we're going to be dealing with in January. I'm going to go through some things here. This is on the 3D model, and we're just looking at a couple of things. ISON is 52 million miles from the sun. Notice the date in the top right, the 16th. Now, a couple of inconsistencies in the model here. Maybe they just had to go in and get it as close as they could. On the 16th, ISON is 52 million miles from the sun. You see this? Now we'll go to the 17th. You see 49. That's 3 million miles per day, 52 to 49. That's what the estimate is. Now, a couple of days ago, it dropped to 2 million miles for one day. I'm going to kind of work through this. Show you a couple of things here. 18th, 46 million. That's 3 million more miles. 19th, 42 million. You see that? Now we jump to 4 million miles per day from 46 to 42. So that's why that bow shock. Now these models are guessing, but that's why that bow shock is starting to appear. It's speeding up and getting hotter. It's getting closer, which increases the solar density. And every time it goes through one of those solar flares you saw, that's going to increase all the activity, the possibility of it heating up, breaking apart. I'm just stepping this through. I'll show you something. Now, after this thing comes around, it's going to be traveling on between the 28th. You see it's 3 million miles. Now let's watch it on the 29th. You can't see it. You'll have to zoom it up, but it's 11 million miles. That means it has traveled 9 million miles from Thanksgiving Day to the next day. 9 million miles. It's extremely fast, guys. That's my concern. You think we got a bow shock at 3 million miles now per day? Now go to 9 million miles per day. You think it's going to hold together? It's going to, man, if it does, it's going to be one tough object. I tell you, we're going to watch it. Now I'm going to talk about the next event, and because we're looking at things like debris trails of meteors and meteor showers just with Inky, and we've seen this before, but I want to point out a couple things about it. That blue line is the center of the debris trail. But this thing is fanning out, and you saw it on the image from last night, and you see it in these images of ISON now. It's not a straight line debris trail. It's much, much wider than the Earth. Okay? This thing is extremely large. But what I'm going to do is just step through the center of the trail. Now, which is, if you think about the fan out, you can add a day before or 2 days before and 2 days after this. But through the center is 7 days of passage through this, whatever's left. Now, the gases and all will probably be blown away by the solar flares and things like that, the solar wind. But again, because of the debris trails, what we call meteorite showers, that will still be there. We're watching it, guys. It's a heads up. Be safe.